All right, everyone, we're back. All right, hope you had something to eat and something to drink and revive the energy. We're going to have a very intense final session here, and we're going to pick up from the back of the paper. All right, so we closed off session 1 with vectors. Tricky question, doable but tricky. What we're going to pick up from trigonometry. Okay. All right. Da da dee da 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 da. All right, so this is where we left off, right? So we're gonna go to question 9. All right. Where's my GDL? GDL? Not here. Okay. Where's everybody? Lonnie. Only doing in the waiting room. Zahenia? I'm probably soon come. All right, I'm soon come. All right, so we're gonna pick up from here. Geometry and trigonometry. All right, let's get into it. In the diagram below, E, C, G, and F are points on the circumference of a circle. Kickstart that part now. And that sentence is a well-renowned sentence. Well-renowned. This part here. I need you guys to make sure if you not see this. If you guys see this on the exam, know that this shape is called a cyclic quadrilateral. See, notice I haven't even think about what you're asking me about it, because I'm analyzing my circle. So that sentence here, please look out for it in case you see it. Chances are there's a cyclic quadrilateral there. Now, very important, a cyclic quadrilateral, what are the rules that surrounds it? Let me jot them down here. So for a cyclic quad, we know that the opposite angles adds up to 180. So opposite angles sums to 180 degrees. Very important. So right away, even without thinking too hard, whatever this angle be, and the one down here, they add up to 180. That one we know for sure. And I also know that whatever this angle be, this one and that one adds up to 180. So that much I know just off just the first sentence in the instruction. All right. So for a cyclic quadrilateral, very key, very important. This in blue here. For the cyclic quadrilateral, the opposite angles adds up to 180. So the ones that are in blue facing each other adds up to 180. And the ones that are over here, I should use a different color, but all right. Them two here, over here, so add together to give you 180. That much I'm sure about. And next thing, remember, I'm basing all of this based off of one sentence alone. You know? The sentence alone tells me a lot of things now. It also tells me, again, that the exterior angle of a cyclic quad is equal to the interior opposite. So the exterior angle of a cyclic quadrilateral is equal to the interior opposite. So right away, I can grab another information here. Without thinking too hard, I know right away that this angle right out here, this angle right out here, no, is that an exterior? No, that wrong. No, that wrong, guys. That's not an exterior angle. Oh, so that one not going to work. All right, so no worry about that. So I can just erase this one. I know I'm gonna leave it there. I'm gonna leave it there just in case it might come up. Just in case it might come up. Shmir, your microphone is unmuted there.
Oh, sorry.
That's fine. All right, sorry about that one, guys. No home page got. All right, so this one right here in black, we're not even going to use that one, but it's okay, it's fine. All right, let's get to the question now. So it says EG is a diameter of the circle. EG is the diameter of the circle. Now, is that sentence alone there? Again, guys, this one here, EG is the diameter of the circle. That gives me another information that I need. When a diameter is in a circle, you see, chances are it creates a 90-degree angle. Now, what should the 90-degree angle is, guys? The 90-degree angle is right here in yellow. So wherever there's a diameter, there is a 90-degree involved. And there's one over here as well. That's also 90-degree. That's a rule in mathematics. So this thing that I'm drawing here in yellow, right here, this shape, this thing here is a right angle triangle. All right? Because of the diameter, that automatically is 90. All of that angle is 90. And also the one over here as well. All right, so that information there gives me that. Watch this now. The tangent AEB, so that's this thing down here, the tangent ABE. That's the tangent ABE. So the tangent ABE is parallel to CD. So the tangent ABE is parallel to this thing right here. And if you don't know, you're going to learn now that whenever there are parallel lines involved, chances are that there are Z-shaped angles involved as well. So if I connect these two parallel lines right here again, you'll see that there's a Z that is right here. Let me show you the Z using a bigger marker. So chances are there's a Z. Look at the Z right here.
There's another one as well, sir.
There's another one on the other side as well. So there's a Z right here as well. So those things will come into play when it comes to getting certain angles, right? If you can't identify these little Z-shaped angles and parallel lines and opposite angles add up to 180 and diameter makes angle of 90 degrees, circular theorem can be a challenge. Again, if you have not seen or learned this topic, I have an exclusive video that demonstrates the application of the theorems, and I also have a video that explains what the theorems are. All you need is one request. And you just take your time and watch it. All right, so we have that. So you see, notice how now, guys, no, I'm going to start reading the question. All I'm doing is just reading up top. Up top is where all the clues are. Up here, so them there. Angle ECE is 68, which you can very see. Hold on. Don't answer, that's 68. And EFD is 106. You can see it out here. EFD 106. Now that we do a little analysis now, and we look at these things, let's see what they're asking us to find. It says, determine the value of each of the following angles. And you're to show detailed working where necessary, but you're also supposed to support your working out with reason. geometric reason that is. And so you're asked to find the angle ECD. When an angle is named with 3 letters, the angle is located at the letter that is in the middle. And that angle, that letter must be made by the line E and D. So ECD, where is C? So E right here, C, D. So we're looking for this angle right here. That's the angle we're looking for. And that's very, very easy to find because this angle is actually equal to 68. Why is it 68? Because of what Javari said earlier. Javari stated that there was a Z-shaped angle on the other side right here. So if you notice then that the angle right here is equal to the angle right here. All right, you should see that clearly. So that's it. So the answer for that question would be that ECD is 68. What's the reason? Alternate angles are equal. Alternate angles are equal. That's it. Oh, Lord God, watch out. We have space. Oh, my Lord. Yeah, you can write it there. So you can write your answer ECD 68 and write your reason and explain yourself down at the bottom. All right. Lovely. Everybody okay with that one?
Yes, sir.
Ashley says she good. All right. Next one. CEG. So CEG. So the angle is at E again. It's at E, but it's on the other side of, oh, not on the other side. At E, CGE, CEG, CEG, where's C? So C is right here. Where's E? E is down here. And where's G? Up top here. So it's the angle right in here. So ECG, that angle right here. That's the angle you're looking for. The angle down here, right here. So, all right. Now, ladies and gentlemen, folks, look at this now. Watch my marking. Watch my marking. Now look at this, guys. The diameter comes down straight to meet the tangent. So because the diameter comes down straight to meet the tangent, what happens is that the angle right down here, inclusive of that, is 90. So when a diameter meets a tangent, the angle formed down here is 90. And out of the 90, you can clearly see that you have 68 out of the 90. So the rest of the angle right here, because the two of them come together now. Two of them come together and make the 90. So out of the 90, you have 68. So therefore, you can see that this angle is equal to 90 minus 68. And that works out to be 22 degrees. What's the reason? The geometric reason is that diameter is perpendicular to a tangent. That's theorem number 2. The diameter is perpendicular to a tangent. And if you want to be very specific, you can just say diameter. What's the diameter? The diameter is what? GE. So diameter GE. So diameter GE is perpendicular to the tangent AEB. And that's the reason. So the diameter GE is perpendicular to the tangent. And once you tell the marker that, the marker will know where you get the 90 from. Because you have to give a reason for how you get this 90. Where this 90 come from? Out of the blue. Or you just come up with 90. So, all right? And that's the reasoning. All right, moving on to the next one. CGF. 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 Let's go over our diagram. CGF. C is right here again. Where's G? G is up top. It's a G. That's a G, right? I think so. Can I color it up? Should I clean up my diagram? Let me clean up my diagram.
Yes, sir, that's a G at the top.
Oh yeah, oh yeah. I'm just clean up the diagram so we can see it. Put one of my markings up, right? Right, good. Let me put it back. Good, so that's it. So CGF, right? All right, good. So we're looking for this angle up here then. So we're basically looking for this angle right here. But remember now, you know, that this angle right here is 22. Remember, so that angle is 22, you know. And remember that this angle up here.
Sir,
Yes,
the
there.
writing in black, would that apply now?
It would partially apply. We need this side first.
Okay.
We need that piece first. So if you can find this piece right here, that would be good. Because what we know for sure is that this angle up here and all of what is down here adds up to 180. We know about that. But the problem is that we don't have this angle in between here. So if you can find it, that would be good. Now watch this now. Right? Watch this now, you know. This is 90, you know. That's 90. And this is 90. Not true. That we know for sure. Let me see what I'll go on this now. Let us see. 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 All right. So look at this now. I think we don't know how Antoine answered this here. Remember, so we have a little Z angle right here, right? So these co-interior angles add up to 180. So this angle plus this one down here adds up to 180. That we know for sure. So those two right there add up to 180 because of the co-interior angles. So I can start off by saying angle.
Sir.
Yes, sir.
And the outside that angle that.
No, it doesn't matter. Remember, say the Z angles are equal, you know, but co-interior angles add up to 180.
Okay.
So if it's the Z, it's equal. But if it's the co-interior, it adds up to 180. So these two angles right here adds up to 180. So I can find this one right here, so. Because this one would be what? 180 minus 106, which should therefore be equal to 74. Not sure. So this angle right in here, so, is 74 degrees. Now, once we find that, now we can find a little piece in here, so. Because if that angle is 74 and all of it is 90, because remember, it's still the diameter now, that means the tangent. That is 90. All over here, so it's 90. And out of the 74, then this angle right here is going to be, I think it's 16 degrees. Because it would be 74 from 180. So therefore, we'd say that the piece of angle there is 74 minus 180. Now, how do we put it on paper? That's the problem, you know, the challenge now. How much marks is it worth? 2 marks. It's just to put it on paper now. So to put it on paper, first tell them how you get this angle right here. That's the first thing. All right? So to get that angle, you're going to say angle BEF, this angle right here, the 74. So BEF, angle BEF is equal to 180 minus 106, which is equal to 74. What's the reason? Co-interior angles. Co-interior angles. All right, that's the first step. Next step, them say show detail working out, where necessary. Now, after we get the 74, now we say that angle what now? GEF, that's this 16 degrees here. GEF, so angle GEF is equal to 90 minus 74. Which is equal to 16 degrees. What's the reason? Diameter is perpendicular to tangent. So that's how you got the 16. So therefore now, finally now, therefore, this angle right here, CGF, is equal to 180 minus the 22 and the 16 together. Because from the onset, we don't say the angle at G and the angle down here at E measure 180 because of the cyclic quadrilateral. So therefore now, this is equal to 22 plus 16. So that's 180 minus 38. And that's equal to 142 degrees. What's the reason? Opposite angles of a cyclic quad are supplementary. So opposite angles of a cyclic quad are supplementary. All right. So that is how you would answer a question like that. All right. So tricky question. All right. You have to know your theorems then. That's pretty much all I'm saying. You have to know your theorems. Let me check the chat to see if there's anybody who wants to come in. Oh yeah, there's a few. All right, so please feel free to watch back this part of the recording, right? And just kind of slow it down, pause it, and analyze as I'm explaining and as I'm finding out the stuff. Analyze it. Just give yourself a chance. Remember that we're going to have a circuit theorem workshop during this week.
Sir.
I don't. Yes, there.
I was trying to calculate it, and based off you're getting the same thing there.
You got the same thing
The
like
same
me?
answer that, yes, and I use the same thing that you have in black up there. The same thing that you write in black.
Diameter, perpendicular symbol, that.
The exterior angle, the interior. The opposite angle of the interior would add up to the
180.
180. Yes. So when I would take the opposite angle, the interior angle, that is opposite the interior.
Right.
The exterior. The interior that is opposite the exterior. Is the whatever.
I guess you have those probably. If the reasoning that you wrote down, if there's some merit behind your reasoning, you'll get the marks. Because if we know students, the amount of theorems that exist, we know you're not going to remember everything. So if you wrote down something, right? All right. So first of all, for you to get the right answer, there has to be some merit behind what your calculation. There has to be some merit. You can't come up with 142 without having some merit. Now, your reasoning may not be accurate, but if you can express understanding of how you got to your answer, then you'll get full marks. So no to worry about writing the exact thing. Because when I was doing my exam, I never remember half of these rules. And I got a distinction. Okay? So if you're worried about that, don't worry. Just write what you understand. All is good?
Yes, sir.
All right. So that is it for that question. Oh yeah, I was saying keep your eyes open for not open. In this week I'm gonna be doing a circuit theorem workshop. So we're good circuit theorem and trigonometry. So we're going to be working extensively on about 8 types of these questions one day in this week. All right, so don't worry about it. You'll be okay. All right. Somebody help me read. Anybody? I want to get involved. Feel distance from one. Anybody can read. Somebody go ahead and read now.
From a harbor, H, the bearings of two ships, Q and R, are 69 degrees and 151 respectively. 151 degrees respectively. Q is 175 kilometers from H, while R is 242 kilometers from H.
All right, thank you so much. Thank you. Lovely. So, as per usual, we are going to, as we read, we are going to analyze line by line and see what we want to, as we don't want to read and then I try to interpret. As we read, we interpret. So, for Sujani, just as she said, from a harbor, H, the bearing of two ships, Q and R. So these are the two ships here. Ship 1, ship 2, right here. Those are the two ships. Okay? And they are 69 and 151. So therefore, Q is on a bearing of 69, which you can see right here. And remember, say bearing is measured from north in a clockwise direction. That is very important to understand which direction bearings take you. You can see this 69 right here is for Q. So Q, it's a Q here. Q is on a bearing of 69. See the bearing come around this up, 69 degrees there. Good. All right, and then the 151 now is what you're looking at. And you're probably wondering, where is this 151? This 151 is inclusive of the 69. So all of that there says 51, 151. Because them say R is an bearing of 151. So to get to R, you have to carry around the arc, come all the way around here. So all of that there is 151. Okay, 151 degrees. So the 151, although they don't tell you, it's inclusive of the 69. Okay, all right, let's continue. What else them say? Q is 175 kilometers from H. So from H here, Q is 175. So therefore, if I clean this diagram up here, I can put my 175 right here. So let me put back my 169 right in here. My 151. All of that is 151. And remember, the 151 start from north and come all the way around to here. So, all right, we should say understand that. And then the next part says no, R is 242 from H. So R is down here and it's away from H. So that is 242, which you can see right here. All right, good. So now that the analysis of the information at the top is done, ready for the question. It says complete the diagram above to show the information that was given. 1 mark. So you get the 1 mark, you put in the 175, and you put in the 151. That's the 1 mark you get. Okay. Next one. Oh, and when them say copy the diagram, please redraw the diagram. Oh, well, you don't need to. You don't need to do that. You don't need to do that. Well, you can copy the diagram if you want to. Right? You can redraw it if you want to. Now, next question says, calculate QR. Calculate QR. So they want to know the distance from here to here. All right? So now, earlier Javari made a mistake when we were dealing with a right angle triangle. And he mentioned something that was supposed to be used in a different type of triangle. Ah, there it is, Antonia. All right, there it is. All right, so now we're looking at a triangle that is not right angled. And because the triangle is non-right angled, the only two things you have to consider here are potentially, and when I say potential, we don't know which one yet until we do the analysis. It's going to be the cosine rule or the sine rule. One of them. We don't know which one we're going to find out.
I have a question.
No. Yes, I would love to get a question.
Since the entire thing is 151, that empty angle right there, it would be 69 from 159 would be 82, right? That angle right here.
That is absolutely correct.
Okay, thank you.
And you're going to need it as well, because that's what I was about to discuss. Because to use the cosine rule, you must have two sides and the angle between. So I would have come to you now to say to you, how would we find the angle between? Well, you beat me to it. So good job. So therefore, to start off this calculation here, we're going to need angle QHR. So angle QHR is equal to 151 minus 69, which Shamir says is 82 degrees. And we got the 82. So now that we have the two sides and the angle between, we can therefore then use hence C squared will be equal to A squared plus B squared minus 2AB times the cosine of theta. I'm going to take a moment before I get to the calculation here, and I'm going to run this back up here. So hold on. So I'm going to go all the way back up to the front of the formula sheet because I want to show you the formula that's there. All right, take a moment just to make sure so you understand everything. There's the cosine rule right there for you. Now, please bear in mind that even though you're seeing A square at the front, B and C, the only difference is that I put the A square where the C squared is. So the only difference between what I'm writing down on paper and what you're seeing is that I have my C square at the front and they have their, A square at the front. That's the only difference. But the formula doesn't change. It's just that I'm using a different variable to represent my unknown variable, my unknown quantity. So they are using A, I'm using C. That will not change the price of rice. So I'll put that up there just so you understand that. All right, so back to regular programming. There, back to regular programming. C is going to be our unknown side, which is QR squared here. And then A and B would be the 175 squared plus the 242 squared minus the 2 times the 75, 2 times the 175 times the 242. And then we're going to multiply it by the cos of the angle that Shamir calculated to be 82. All right. All right, so use up some calculators for me now, girls. I know Geneva and Wheatley is always in the chat. Thank you very much. That's for the first one. No, I don't need them one at a time. You know, we have to cut the working out short. We have to just do them one time, Antonia. So what is 175 squared plus 242 squared together? You get 89 point something. You sure? 89? I don't know that. That's what
So 89,189.
Oh,
Yeah, that's correct.
oh, that's what she said. 89,000. Okay, sorry, my bad, Antonia. 89. Could I assume it's 89 point? 89,000 how much?
189.
89,189. Point how much?
No point.
And a point not there.
No point at it. All right, good. Antonia said, wouldn't GEA also be right angled? GEA. Oh, sorry. That was a different question. Hold on. I'm so far up into the chat. Okay, that's way far. Okay, you'll have gotten clarity already. All right, good. And then I'll go ahead now and work out all of this thing over here all one time. One single time. -2 times 175 times 242 times the cosine of 82. One time. All right, so she's getting 11,787. 11,787.96. Confirm that. Somebody is confirmed, please.
Correct, sir.
All right, go ahead and do the subtraction. Thank you. So QR squared. This is QR squared. All right, when you do the subtraction, what are you getting? All right, so she's saying that she's getting 77,401. Can you confirm? 0.04. Confirmation? Confirmation?
Yes, I got that as well.
Okay. All right, 2 girls in the chat. All right, so QR is equal to the root of 77,401.04. All right, and what's that? All right, somebody's saying that it is 278.21 kilometers. And that's it. That's your answer. All right, so make sure you make a note of that. Cosine rule and sine rule is very, very common on these type of questions. Now we're looking to find out how far due south. Due south is a keyword. Make sure you know where this be. Due south meaning a straight line down. So how far due south is ship R from H? So ship R from H. Ship R from H. How far due south? So to do this now, we have to do a construction. So how far due south? So to do this now, we have to do a construction. So how far due south? So we need to know how far. So this is 90, and how far due south is that? So the only thing we need now, we don't need this section here, because that is not due south. Due south means say we need this length right here. So how far south it there? How far? Because we already know what this distance is, which is 242. We don't get that. So how far due south? Now look at this now. Watch this now, guys. This is such a nice question. Well, to
That
me,
is the Pythagoras theorem.
Pythagoras theorem, you would need this side to use Pythagoras theorem. What you need is to use a ratio, because watch this now. You have an angle right here. Now remember that all of this angle measure what? 180. And you have 69 and you have 82 already. So all of this angle measure what? 180. Correct? All of that angle measure 180. So go ahead for me now, guys, and add up. Add up 69 and 82 and take it from 180 and tell me how much you get.
29.
This angle right here is 29 degrees. So again, Javari, temptation to use Pythagoras theorem, you're gonna find a challenge in using the Pythag, because for you to use Pythag, you have to have two sides, and we are actually looking for another side. So if we knew what this side was, then easy squeeze, but we don't. All right, Antonia says she's going to use sine, which is opposite of hypotenuse. Let's just test if she's right. So we are looking for this side over here. And we don't have the angle in front of it, so we have the adjacent. We have the angle adjacent. This side here is the adjacent, Antonia. That's the adjacent. Reason why that side is the adjacent is because the angle in front of it is not known to us. You could use sine if you knew what this angle was and you can find it, but that's too much work. I already have the 29, so since this is the 29, this is my opposite. I'm not looking for that side. I'm looking for this side at the side here. So what I'm going to do is that I'm going to use adjacent over hypotenuse. So I'm going to be using cos. Now, just to make sure, I don't want to say you're wrong, right? If you have this angle here, Antonia, then you could use sine. So depending on which angle you're using, then in fact, you know what, I'm going to use both of them. Because I don't like to I don't want you to come up with an answer and then tell us, no, it's wrong. It's not wrong. It's just that depending on which angle you use. So we're going to use both of them. Sine is opposite over hype. We're going to use both of them. You're going to get the same answer. All right, so I'm going to do the calculation up here. So if I'm using cos based on what I've been given, the 29 here, I'm going to cos 29. And then the adjacent would be the side I'm looking for, which is going to call this x. Going on a name for it, so call it x. I'm going to call it hx over 242. All right, the unknowns at the top, Javari, what do we do? Correct, Geneva, cross multiply. So hx is equal to 242 times the cosine of 29. What is that angle? Oh, sorry, what is that calculation? $111.66. All right. Okay, lovely. All right, and if we go back over here now and we use what Antonia wanted to use, then Antonia, you cannot sine 29. You have to sine the angle that is in front of the side you're trying to find. So the angle that we would need right here is this, and that angle would obviously be, let me see here, 20 from 90, 70, 61. So if you sine 61 and put the opposite this time, which is the side you're trying to find, hx, this is h, we just leave with this side x here, over 242, and then you'll see that hx is equal to 242 times sine 61. Can you confirm if you got the same answer? Okay. Confirm. Just should get the same answer, 211. So your mistake is not with the ratio. It probably would have been with the angle that you chose to find. All right, so hope you get some clarity there. All right, and I guess that is it. That's it. So question 9 and 10 out of the way.
Well, go back down there, sir. So, empty spot. No, go down. Right there, sir.
No, we just answer. I just did the calculation up top. My bad. Sorry. The calculation for that empty spot is these two here. All right. So feel free to just do a quick little review of the recording. Trust me, it will help you. All right. So we're moving up now to question 8. Here. All right. Give me a minute, guys. Let me just go grab a drink. I'll be right back. All right, guys, I'm back. All right, good. We are back. Back. Section 2. So this would be the question that would use to start section 2. And this is linear programming. All right, those who are in my class who would have done linear programming. Again, there's a full disclosed tutorial on linear programming and what it entails. So let's get into it. Marla buys 2 types of mobile phones, B-Flow and C-Flex, from a company to retail. So she will sell them back. So she have 2 types of phone. Let me underline those because I think those are going to be important. B-Flow and C-Flex, 2 types of phone. She's going to sell them back. All right. Now what she's saying now? One B-Flow cost $60, while one C-Flex costs $80. You notice I'm underlining stuff? I'm underlining what's important in the question. So one B-Flow will cost $60 and one C-Flex will cost $80. That's going to be important. Next thing, she buys X number of B-Flows. So right away, I can see that they're assigning the letter X to B-Flow. And then buy Y amount of cellular phones. So that means you're assigning the letter Y to C-Flex. So X is being assigned to B-Flow and Y is being assigned to C-Flex. All right? And then they give us another information here. They say Marla must not. What keyword here? Not. That means that she not to go past that amount. So Marla must not spend more than $1,200. You have to write an inequality to represent this particular information right here, using whatever is up top. So my question to you now is, they're talking about money spending. How much is it that one B-Flow phone costs, based on what you've read?
X.
No, the question is how much does it cost? You're correct.
$60.
$60. So $60 multiplies by the amount of B-Flow phone bought, plus how much for your C-Flex phone?
$80.
$80 times the amount of flow.
81.
And she must not spend. That means it has to be less than or equal to what? 1,200.
1,200.
That's it. Done. That's it, guys. That's it. All right. Shamir, your mic is full. It's unmuted.
Oh, sorry.
All right. So that's it. That answers that question. So hopefully everybody got that. No, we're not done with up top, so careful, because they mentioned some other stuff up there that we haven't used as yet. The number of B-Flow phones. So any amount of B-Flow phones that was bought must be what? Look at this. Greater than or equal to. So we have that sign there. So what represents B-Flow phone? X. So X represents B-Flow phones, right? And it must be greater than or equal to C-Flex. What letter represents C-Flex? Y. Write down an inequality in X and Y to show this information. So therefore the answer is just any amount of B-Flow phones bought must be greater than or equal to Y. That's it. Done. Yeah. I know what you guys are saying. So is it always this easy? Yes, it is always this easy. It's because of the whole words, see? And I think it's something hard. It is not. all my students who have joined my linear programming class will tell you this is how it was, this is how it has always been, and this is how it will always be. So 1 mark. That's it. Now them say must represent the two inequalities, which is the two that we just created. That is on page 22, which if you do it, you're going to represent those on the grid shown below. And you must label label as R the region which satisfies both inequalities. All right. Now, somebody from my online class, or not online class, somebody from my group of students that I've taught this topic. The question I'm going to ask you is, for these two inequalities, they are both lines, by the way. They are both lines. The question I'm going to ask is, are these lines cutting the X? Are they cutting the Y? Or are they cutting the X and the Y? And how you know? Anybody can recall from that lesson? How do we know when the lines is crossing the X and the Y, or X or Y or both? How can we confirm if the line is going to look like this, or is it going to look like this? Sorry, or is it going to look like this, or is it going to look like this? How do we know?
So go across the X, the Y.
It's going to cross the Y. Are you saying that the Y alone? You have to be very specific enough. Is it crossing the X alone? Is it crossing the Y alone? Or is it crossing both X and Y? Looking at equation 1.
Both.
If it is greater than, less than, or equal to.
That's, you're saying that's how you, so what's the answer then? Or is it crossing the X?
It's for X or Y.
No, I want to know, is it crossing the X or crossing the Y or crossing both?
Both.
Both. And you know this how? And you know this how?
Because it's greater than or equal to X, greater than or equal to Y.
All right, so you're slightly, the reasoning is off there. So you're correct, the answer is correct, but the reasoning is incorrect. What makes you know that this line is going to cross both axes is the fact that there's an X and a Y in the inequality. That's it. So if I had something like 60x is greater than or equal to 1200, that's crossing the X alone. If I had 60y greater than or equal to 1200, that's crossing the Y alone. But because I have 60x plus 80y less than or equal to 1200, then I know that it's crossing both axes. All right, so Ms. Gentles, make a note of that. All right, now the question is, how do we get this thing to go on the graph? To get it to go on the graph, we need to find out where is it crossing the X and where is it crossing the Y-axis. Where is it crossing the X-axis? Where is it crossing the Y-axis? Where exactly?
60 and 80.
Go try, but remember, the 1200 is going to affect that. You say if it was 60x, you say if it was x plus y equals 60 or x plus y equals 80, then you could say that. But it's 60x and 80y. The 1200 will have something to do with that. So anybody remembers that when you're finding the x-intercept, so remember this now, when you're finding the x-int
equals 0.
All right, let y equals 0. Or better yet, anybody can tell me the shortcut, me tell you? Start with the I. You must do something to y. I. Very good. And to ignore the y. So if we have, so like we have, okay, I have to carry the calculation down here. Do I have to carry it? I'm not enough space. I'm not enough space. I'm going to go work it out up here. So if I want to find the x-int, I'm just going to say 60x is less than or equal to 1200. Just ignore the y. Just ignore it completely because 80 times y, 80 times 0 is 0. So if I divide both sides by 60, I'm going to end up with x is less than or equal to, is that 20? Confirm it, please. I think it's 20.
Yes, sir.
20. And if I wanted to find the y-int, then I'm going to end up with ignoring the x. So I'm going to end up with 80y. I'm going to end up with 80y is less than or equal to 1200. So y is less than or equal to 1200 divided by 80. Talk to me. How much you got?
15.
How much you got?
15.
Javar, I'm not hearing you. You talk and come up your microphone.
15.
15. Okay, 15. So this means now, ladies and gentlemen, folks, that I'm going to find 20 on my x-axis. I'm going to find 15 on my y-axis. Let's go down to our graph and find 20 on my x, that is all the way out here. And I'm going to find 15 on my y-axis all the way up here. And I'm going to use a ruler now and I'm going to connect those two lines. So forgive me, guys, as I struggle here. I almost get it now. Oh. I almost get it. Wicked. Aye. Yo, we get it good, guys. Wow. That perfect. My God. Perfect. So this is going to be, this line is going to be called, let me see here. This line is going to be called 60x plus 80y is less than or equal to 1200. That's the equation of that line. Okay? And then now, this next line up here now, is it crossing the x, is it crossing the y, or is it crossing both? Is it crossing the x?
The Y.
Both?
It's crossing both. So like you want to say y, Jabari. Why I say?
Yeah, Y, I say.
But remember, we just discussed it if it has x and y in it across both. So that we just say up here. Remember? If you want to know if it crosses the x and the y, if you see a x and a y in the equation, it's crossing both. So correct. I think it was Shamir. Was that? I think it was. So it's crossing both, sir. All right, so where is it crossing both? Where it looks like this, it's crossing x at 0 and it's crossing y at 0. When there's no numbers involved, it's crossing it at 0. So they're both going through here. Now, this line here, watch this now, guys. If it's passing through here, remember, so you can have a student that does this, 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 so you can draw it anyhow. That's a problem. The student can draw it anyhow. You need this line to be perfect. So for this line to be perfect, ladies and gentlemen, this line has to pass through 5, 5, 10, 10, 15, 15. It has to pass through equal numbers on both axes. So wherever 5, 5 meet, 10, 10 meet, and 15, 15 meet. And it doesn't have to be 10 and 5. It can be 1, 1, 2, 2, 3, 3. But because of the numbers that are on my graph, I'm using those. So 15, 15. So 15, 15. 15. Right, this one. It says crossing both. All right. So now I'm going to draw a straight line through here. Perfect. So it's passing through that line there. So this line now is going to be called x is equal to y. Or y is equal to x, same thing. So this line is going to call x. This line is going to be called x is equal to y. All right. Any questions so far as we're going through? Everybody starter
You say you can write y equal to x as well.
It's the same thing, man. Remember, say if you taller than me, you know, me must taller than you. Sorry. Well, if you, yeah, you can do that. If you're taller than me, then it means that I'm shorter than you. So x is equal to y has to be equal to x.
Can you show back the question, please?
Sure. The question right here. It says represent the two inequalities that we did above on the graph.
Okay, then.
Label the region R. So the region now. Which region? Because there's several regions here. Now there's one here, there's one here, there's one here, and there's one here. So which region are we going to label? Well, based on the fact that them said this equation says less than or equal to, that means it must be a region below this line. All right, so we have to shade the region that is below that line. But this one now is x is what? Greater than y. So it has to be a region that is above this line. I'm going to use a different color ink here. So a region that is above this line. You don't know, show. Still purple. So anywhere you see the red and the purple overlap, that's the region. So which region? Because I'm shading above that line and I shade below the line. So which region does the red and the purple overlap? The left, the bottom, the top, or the right? Correct. And then someone must label it. Must label it R. All right. So must label this region R. Like I said, feel free to check out my linear programming. I have 2 videos on it. It discusses the fundamentals of linear programming, and then it shows you how to draw a line on a graph. So feel free to request the link for that particular video, and then you can take your own lick of sweet time and do your thing once I'm not online with you. Okay, so that is the region. All right, and that's it. If you notice now, ladies and gentlefolks, there are so many teachers. When I'm scrolling on YouTube, I'm looking to see what's going on in the teaching space, right? And this is no way, shape, or form criticizing anybody. When you search YouTube, majority of the questions that you guys will encounter on the exam, many teachers are not teaching it. I don't know why they're not teaching it, but they teach trig, they teach everything or every topic where the students like. But then the questions like this, you don't see a lot of persons teaching this. But it comes on the exam. And when students see this on the exam, then flip. That's how I get my success, over the years that I've been teaching. I don't run away from certain topics. I teach them, break them down and teach them. So my students can end up doing questions that are not usually attacked, All right, moving on next. All right, so now they're saying down here, guys, that the total number of mobile phones is represented by x plus y. So the total number of phones, that means together, B flow and C flex come together, is represented by x plus y. And according to the graph on page 23, which is the one that we just plotted, what is the largest possible values of x and y? In other words, they want to find out what is the largest amount of B flow phones and C flex phones that must be bought. So when you go on the graph now on that region, it can either be up here, right here, I can't down here, so because down here is saying what? 0, 0. No phone can be sold down there. What is the coordinate of this region? I'm not fully accurate, right? My graph is not perfectly drawn, but I'm going to see that it is right at this point, right? I'm going to zoom up this up. It's going to be right at this position right here. If I draw it more accurately, it would be right there. What is the coordinate of that position? I wish I could like given or like one GIF or something if you don't get it right.
9, 9.
9. You know, you're correct, sir. You are very correct, you know. 9. So what does this 9 mean? This 9 means that it's going to be 9 B flow and 9 C flex. And then up here would be what? 0, 15. No B flow and 15 C flex. So no B flow and 15 C flex. C flex. All right, so that's what it means. Let's look back at the question with them say now. It says, what is the largest possible values of x plus y? So up here, so 0 plus 15 is 15. And here's a 9 plus 9 is 18. So what is the largest possible values of x and y? What do you think is the largest possible values of x and y? Oh, Antonia, he got the 9 by reading it from the graph. The 9 is 1 stroke before 10. To get to this position, we have to go across 5, 6, 7, 8. Hold on. 1, 2, 3. Hold on. No, hold on. Antonia, you see right though. Javari, like you mislead the class, you know. 0, 1, 2, 3. No, sir. Something right. Go check that again. So the spaces. So right here, so is, let me see. The scale is 1, 2, 3, 4 to 5. Scale is 4 to 5. I don't know what kind of scale is this. It's a weird scale though. But this scale is saying 4 centimeters to represent 5. No, so the 9. So it's not 9, Javari. I guess why Javari said it's 9 is because it's 1 stroke before the 10. But looking at the scale based on the question, 8.5, I think, but we're not going to have 8.5 phone.
That graph is weird, sir.
Yeah, weird. But we're not going to have 8.5 phone Geneva. So you have to think about the numbers then. All right, so how many spaces between the 0 and 5? Because Antonia showed us a trick last week where we can determine how much each line represents. There is 4 spaces. So 5 divided by 4 is equal to what? 1.25, that's all. Right?
Yes, sir.
This is 1.25. This is 2.5. This is 3. This is 2.5. Let me see. 1.25. 2.5. Two and a half. No, so that much in right, you know. Or is it 5 divided by 3? What's 5 divided by 3, guys? Because the 3 spaces in between us. So 1, 2, 3. What's 5 divided by 3?
1.6.
1.6. All right. So multiply. All right. So 1.6. So we're just gonna say, all right. So here we're gonna just to get an accurate value, we're gonna say that each of these lines is about 1.5. So 1.5. Then we're gonna say 3. No, we can't say that neither. Can't say that at all. I think it's 1.25, you know. Yeah, man, 1.25.
Yes, sir. If you said quarter, half, and then 3/4, the next one would be a whole.
Yeah, man. You're right, man. So 1.25. So Javari then, based on the scale that we have, this right here so would that be? So right here so would that be what? 6.25. And then this would be what now? 7.5, right? And then this would be 7.5. 7.5 plus 1.25. 7.5.
8.75.
All right. So, what we did right, like, but guess what happened? No, here we go. Cause think about it. Even though Antonia is correct in saying that how you get the 9, which is correct based on the graph, we're still right because them said the largest possible. So that means that if you round off 8.75 to a whole number, we'll get 9. Oh yeah, we can stick with the 9 then because it's 8.75, yeah. So would that make sense if we just stick with the 9? Because if you're thinking about it logically, it would have had to be 9. So I think it's more like an intuitive question to see what number would you come up with. Because anybody write down no point for your answer, you know them not think. Sorry, if anybody wrote down a point, it would mean that the thought process wasn't clear. Because a phone we are talking about, you know, nobody has 8.75 phone. So round it off, you can have approximately about 9 phone, possibly. All right, everybody good? Good little exercise, good little thought process there. All right, so that takes up that. All right, let's move on down to this question here. All right, so my people, as usual, you would have seen this already. The table below shows pairs of values of the function y equal x squared plus x minus 4. Normally, people, whenever they do this here, they normally leave out some spaces for you to fill out. So if you go on the exam, yes, Geneva, you would write 9, 9. So you'd write 9, 9, you'd write, I guess you said largest possible values of x plus y. So you'd write 9 plus 9. You can either write 8, I would write 9 and 9, and then just to be sure, I'd write 18. All right. So like I said, guys, whenever you get this table, normally some of these things are missing. Right? In this example, none is missing. So I guess it's safe to say we're thankful for that. It says on the grid provided on page 25, you have to plot the remaining 4 points and draw the graphs of the function. So draw the graph of the function. All right, can somebody take a screenshot so that when I scroll down to the graph, you can just tell me what the numbers are? Let's take a quick screenshot so that as I move the screen, you guys can tell me what the numbers are. Because it's hard to go up and down like that. Somebody has a screenshot?
Yes,
Yes, sir.
Good. All right, so now you can see that we already have 4 points plotted already. So what is the point for 0, 0, 0? Which number is underneath 0?
Say that -1, -4.
No, man, under the table. On the table that you took the screenshot of, which number is underneath 0?
-4.
Okay, right here.
Then 1, -2.
1, -2, that's right here.
2, 2.
And 2, 2, that's 2, 2 up here.
And 3, 8.
And 3 all the way up here, which is 8. All right. And did it say once draw a curve? It says and draw the graph, right? So we're supposed to draw the curve. So we're going to go ahead now and make a nice little curve here with purple. All right, not perfect, but you guys would draw it far, far better than me. Now, one thing that I want to make you aware of, guys, when you reach down to this part where you're going to bend the curve to go back up, make sure you just make it dip underneath the line a little bit here. You should say dip. See right or so? You make one like a mouth. Don't go here and then draw across like that. Like what some persons do. Go here, just go right below it a little bit, and then bend it, come back up like that. All right? Just be very aware of that. All right, good. And that's it. That's it for drawing the curve. What was the question how they asked? They said write down the maximum or minimum. So you see them not try to trick you. They are trying to make you figure out whether it's maximum or minimum. should you state if it's if them ask you? If them ask you, they did. So they said write down the maximum or minimum. Is it minimum or maximum, by the way? That's the question. Is it minimum or maximum?
Minimum.
Minimum.
Because that's smile. And the minimum, you can either use the formula, but that's too much work because of 1 mark. The minimum value is down here, so it's a little bit below what? 4. So give me a number where you think would be a little bit. Look at the scale.
4.1.
4.1. So you're saying that each of these represent 1? I don't think so. Try again. Yes, you know you're right. Box cover. You know you're right, boy.
4.2.
No, man, you're right, man. We are talking about you're right. 4.1. Because each of these represent 0.1. 3.1, 3.2, 3.3, 3.4. No, so you're right. A 4.2, my G. Just stress me out in a Javari. So let me see.
4.2 or 4.1?
Negative 4.2, yeah, man. Because it's 4.2, 4.4, 4.6, 4.8, yeah. So negative 4.2. Yeah, man. So the 4.1, so you see, if you wrote down 4.1, you're not going to be completely wrong. It depends on if the marker is just, I guess, frustrated. Or if you work easier, you might enjoy marking the paper, you might get away with it. But this is 1 mark. So I feel like if you express understanding, I think, yeah, you should be okay. But I would just play it safe and just write my correct answer. So the maximum value, the mean value is equal to negative 4.2. Don't forget the negative, please, because it's at the bottom. Please don't forget the negative. That's it. That is it. All right, next one. Use a ruler and draw the axis of symmetry. All right, so guys, the axis of symmetry is the line that runs through the exact middle of the curve. And that is this line right here. So use a ruler and draw 1 line right through the middle of the curve right there. So that's it. That's the curve right here. So the axis of symmetry, just find the middle of the curve. All right, and draw the line right through the middle of the curve like that. Now, if you want to be certain, let us just say you're on the exam and you're completely uncertain about that, about which number where is the middle. You can use this formula here, x equal minus b over 2a. And then that would be minus b. You have to go back to the equation now. A is 1, b is 1, and c is negative 4. So it's just going to be minus 1 over 2 times 1. So that's going to be minus a half. So you notice that the line is going exactly between 0 and minus 1, which is minus a half. So that would be the line here. You draw it, come straight down like that. Okay? So that is it. All right? And that's your functions. And that is your question 8. So that one was very doable if you understand what you're doing. All right? Lovely. Let us take care of this pattern question quick and fast. All right, I'm checking for everybody, make sure them good. All right, so my usual suspects are here. All right. The first 3 figures in a sequence of shapes formed by connecting lines of unit lengths are shown below. So this is very straightforward. You have a house and you have 2 houses joined together and 3 houses joined together, right? It says draw figure 4 of the pattern in the seat. I mean, this. If you see this or anything like this on the exam, you should be grinning. You should be grinning, right? And so, not true. Not supposed to grin, right?
Yes, sir.
Oh, I better say yes. And I see this to be like, no man. I just spend my whole entire year for them give me 4 little house to draw. Hey, Lord have mercy. Poor little house to draw. CXC love you this year. Nice like cucumber. Sweet. Sweet is 2 marks to get me alive. Alive evil. Oh God. I can't wait until next week, Tuesday, when I come out of the exam and be like, sir, mash up that blow there. Sure. Everybody going to the summer, can go on our vacation and laugh and have fun, knowing that when the result is coming out, we are going to be smiling all the way to the bank. Moving on. Positive mindset, people. The number of lines L, right, that's all, in each shape and the perimeter P, right here. So over here, so the numbers represent perimeter. Them numbers here represent the amount of lines made for the shape. You are to study. This is the part I like. Study. So my study and your study different. My pattern and your pattern different. How I see it is not how you see it. So whatever way you come up with it, this is the question where no matter what kind of pattern you come up with, as long as there is consistency behind your pattern, then you're good to go. Let's smile all the way to the bank now, people. Tell me what pattern you see now. Now, I was telling the students yesterday that try to figure out patterns that go this way. You can always check the pattern that goes down, you know. But the pattern that goes down only works for the numbers in this section right here. So try to figure out the pattern going across. All right? Now, what I like to do is, look at this now. These numbers are going up by what?
5.
5, not true?
5n plus 5.
Oh, we don't reach the formula yet. Take time with me, then, mama. Hold on there. We don't reach this yet. We just want to figure out the
5n
pattern.
plus 1, sorry.
Oh, God, no, but I didn't with the answer. Oh, God, please, Shamir, not give me the answer yet, man. Sure. All right, so write this now, people. It's going up by what? 5. So chances are, if it's going up by 5, that means 5 is multiplying this number, and then something else is being done to get that number. Now let's check it. 5 times 1 is what? Because it's going up by 5, you know. So that means that we have to multiply the figure by 5, and then do something to get back this number. So if you notice that every time I multiply this by 5, I have to add 1. 5 times 2, add 1. 5 times 3, add 1. You realize? So as Shamir rightly said that the formula is 5n plus 1. But Shamir start answer the question down here, so ready to help. Alright, so let me go on with the road. Since she want to take over my class. Alright, come Shamir. So it is 5n plus 1. No problem. Alright, but here's so now.
3n.
5. Hello, sir. Me give Shamir a chance. I know about to take over now. Remember see me about the students in my class. Sure. Alright, so come here now, Jabari. 5 times 5 is 25 plus 1 is what?
26.
Alright, take with time, sir. Take with time. I appreciate things so. When I get too excited in the exam when I see I get to grade 1, you know. Alright, so what is being done over here now? What's happening to this one? You're going up by what?
3.
Yeah, so that means that we multiply this by 3, and then we have to do something to get 5. What are we doing?
Add 2.
Add 2. So 3 1s is 3 plus 2. 3 2s is 6 plus 2. 3 3s is 9 plus 2. We get 11. So therefore 3 times
3n plus 2.
When I reach us, I get the answer for this you want. So it is 3 times 5 is 15. Plus 2 is 17. Alright, now, I guess the formula is what? 3n plus 2. Alright. Yeah, somebody ask a question?
You do back over the perimeter side.
I must do it back over?
Yeah, like how you calculate to get the 17 there.
No, the question I ask is, how much is this going up by?
Okay.
3. So that means I did something. I used 3 to multiply this number. And then I did something to the result to get 5.
Okay.
So that means 3 times 5 is 15. And I'm doing something to it. So I've been adding 2 to get 5, adding 2 to get 8, adding 2 to get 11. So I have to add 2 to the 3 times 5 to get 17.
Okay.
All right. Now, reversing it is just the opposite. Remember now, Jabari, if to get the 66, we multiply by 5 and add 1, what's the opposite of multiplying by 5 and adding 1? What's the opposite of that operation?
Divide and take away.
No, you have to do it back the other way, sir, the other way. You're right, but you just say it in the wrong order. Say it correctly. You said divide and then take away. Other way.
So that take away, then
Divide, correct.
divide.
Away, then divide. No, you have the opposite of PEMDAS, you know. Right? So you're going to take away 1 from 66, so you get 65, right? And then 65 divided by 5 is 13. You do the opposite tomorrow of what is done here, because you're going backwards. So if going forward, we multiply by 5 and add 1. Going backwards must be subtracting 1 and dividing by 5, the opposite operation. And then once we get this, and now we easy to get this. Because this now is 3 times 13 plus 2. So 3 times 13 is 39 plus 2 is 41. And you're smiling all the way to the bank. Yeah, man. Solid. So question 7 is highly recommended. You not get nothing too hard. Get a little tricky question here, but enough of Mr. Peer teacher, man, you know you can rub up that it is, man. Answer me, teacher. Yeah. Gucci. All right. What else am I ask us now? Write a simplified expression in terms of n for the difference in d and for the difference d between the number of lines and the perimeter in the figure. That's easy. So the difference is going to be equal to the subtraction of the two formulas. The first formula was 5n plus 1, and you're going to subtract that from what? You're going to subtract what? So 5n plus 1, subtract what? 3n plus 2, right? Everybody working with me? Them say them want a simplified expression for the difference, which means what? Subtraction, difference, right? And them say the number of lines, what's the formula for the number of lines? Number of lines have a formula of 5n plus 1. And them say the what? Perimeter. The formula for perimeter up here is 3n plus 2. So we're going to subtract 5n plus 1 minus 3n plus 2. All right? And that is basic algebra. Everybody near strong enough in that. So go ahead and subtract this for me now. We're going to group like terms, right?
Yes, yes, it have 5n minus 3n.
So hold on now, hold on, wait, now 5n.
5n minus 3n
Mm-hmm.
plus 1
Mm-hmm.
plus 2.
Plus 1 plus 2. So what would be the answer?
1 plus
2n
3.
2n plus
3.
Plus 3. Everybody's in agreement?
Yes, sir.
All right.
Yes,
1,
sir.
you are incorrect. Yeah, man. Setting up. Box cover, no? Yep. Setting up, man. That is very good. Yeah, man. This is how CXC is setting up. Guess what is missing? Anybody can tell me what is missing?
The input value for n.
We don't want the input value. We just want the formula. Something else missing. I know me that catching them, man. I knew I would catch them. What is missing?
That's all for n.
Nope. We don't want to solve. They never say solve. Them say write a simplified expression.
Sir, the D.
The D is there already. See there.
Oh,
What is missing? Something missing. Start with B.
brackets.
Lord, Jesus takes the wheel. Take it from my hands. The bracket. Remember me telling us that when I subtract 2 algebraic expression from each other, the second one has to be in a bracket, because this minus sign is going to affect. So when time come out of the exam, sir, this one question like this here, I mash it up. I'm say, tell me what you do. I'm tell say you left out the bracket. You got what attack. At 2 marks that you just splash me, all because I want silly bracket. So you're sure we have to put the bracket? Yes, you have to put the bracket. Because if you don't, the negative here affects everything on the inside. So you're going to end up with 5n plus 1 minus 3n minus 2. So you end up with 5n minus 3n plus 1. And as much as you put plus 2, I said, I just that alone, sir. Yes, I just that alone. Mathematics is about precision. Anybody in here know about computer and programming? You'll know that one error will cause a program not to run. So you end up with 2n minus 1 instead of 2n plus 3. Big difference. Major difference. And if you want to prove it, all you have to do is just subtract any two things from each other and see what will happen. But we're not going to prove it today. We have more important things to do. All right? So yeah, man, look out for that. Look out for that, people. Look out for that. Don't get caught. Do not get caught. Simple. Everybody all right? Sorry. I'm sorry to do that to you all, guys. I'm very sorry. But it had to be done. It had to be done. All right. Good to go. Let's take on question 6 now. Farmer Brown makes troughs. Trough this? I can't pronounce that word there now. How do you pronounce that word here? A trough this?
I think I think so.
Ask AI how to pronounce this in a man.
Troughs or troughs.
Troughs. Alright, that me I call it. What you want that name? Troughs. Fancy word there, man. Farmer Brown makes troughs to feed his farm animals using wood that is 5 meters thick. Look at where the 5 meters is. Pay attention to where the 5 meters is. Thank you. 5 centimeters thick. So you see that brown space over there, some people? Right in so? That's made from wood. Give me a try it one. Lord of mercy, God. May I try it one. So right in there, so is made from wood. And the space between here is 5 meters thick. From the edge to the inside is 5 meters thick. That's very important you understand that. 5 centimeters thick. Thank you, Miss Gentles. Now, as shown in the diagram below, the troughs are rectangular based. So it's a rectangular trough. Open at the top and have external dimensions of 300 by 190 by 160. So the length of the trough is, the width, the length of the trough, length or width, it doesn't matter. In this case, I'm going to use this 300 to be my width. All right? The length is how long it is. So the length is 190. And the height is 160. So the height is 160, the length is 190, and the width is 300. Or if you want to say the length is 300 and the width is, it won't matter. It won't affect your solution. Now it says show by calculation. Show by calculation that the internal capacity. So you see in the exam on May 12, if you see one question similar to this, and I only mention the word capacity without giving you the clue that it's volume, remember say capacity means volume, okay? So show that the internal capacity or the volume of the trough, the internal portion is 8,991,000. Also?
Yes, sir.
8,091,000. Yeah, that's it. So 8,091,000 cubic centimeters. So firstly, people, volume is equal to area times height. So the first thing. All right, so volume is equal to area times height. Now, as I've emphasized in my classes about area, you can't just say area to be very specific and say that it's the area of the cross section. And because it's a rectangular trough, then it means that the area of the rectangle, the cross section is a rectangle. My bad. So the area of the cross section, we don't say height, we don't say h height, we know that already. So when we say area, it's not just throwing area around, it is the area of the cross section, which is the area of the rectangle. All right? Good. Now, where is the cross section? I'm going to connect it and show you something. And then connect here, so you're not seeing the inside of this trough, right? But down here is the cross section. The top and the bottom. Can you tell us it's opening now? So the top and the bottom is the cross section. The top and the bottom. All right? So the internal part they want, you know. So watch this now. Watch the ball game now, people. Watch the ball game now. So I zoom up for you. Remember the 5 meters thickness, you know. Remember the 5 meters thickness. The width, hold on. First of all, volume.
Sorry.
Yes.
They said they wanted the internal capacity, so why are you using the top of the rectangle?
Because that's the cross section. The cross section is the base, the top and the bottom. That's the area. The area of the base times the height. So you have to use the 300 and the 190 and the 160. But there's a trick with this. Volume is equal to the area of the cross section is length times width, as Antonia said in the chat. Length times width times the height. Now, careful now. If you, first of all, go ahead and do that for me, please. You're in the exam, and this doesn't hit you right away. Go ahead and multiply 300 by 190 times 160, because you're probably not thinking about the 5. So go ahead. Let me show you how the 5 come into play now. Go ahead and multiply 300 times 190 times 160. Are you getting more than 8 million? Correct. You're getting 9 million. So you're short by a couple of 100,000. And the mathematics that you're doing there is not getting you the answer that they are looking for right here. So that means that the 5 play a role. Now watch the zoom up when I zoom up now and pay close attention to what I'm going. We can't use the 300 people. Now remember, say them cut off 5 thickness off of each side. We don't want the outside, you know. That 9,120,000 that Antonia get would have been the volume of the external trough. But inside, here's a wall, you know. It's like a wall, it's like a wooden wall. So inside here's them ask. So watch now. Them chop off 5 off of here, so. And 5 off of here, so. So them chop off 10 off both sides of there, so. So this 300 is actually going to be 300 minus 10, which is 290. All right? So for the width now, remember say for the width now, remember see you have to go boom now and subtract 10 again. So 190 minus 10. So where you get the 10 from? From both sides, people, both sides. It was mentioned that the 5 meters thickness. That's what most persons make the mistake. That's where I made the mistake when I saw this question the first time. Right? I ignored the 5 because the thickness, the cut off piece. So I'm cut off 5 off of the width on both sides. So it chop in like so. And then after is them chop off 5 again. So that is going to be 190 minus 10. So that's 180. Now go ahead now and multiply 290 by 180 by 160. How much did you get?
8,352,000. Hold on. No. Wait.
155. No man, the height. We have to take off 5 off of the height. The height not get affected. Remember saying no? The trough is affected by the length and the width. The height is not affected by the 5 Geneva. How much you get when you multiply those two? 8 million. All right, so we're still short. No, sorry, we've gone over. All right, so Jenny Antoine is saying 160 minus 5 for the height. The height has a bottom that took off 5. Oh, all right, can we do all go on? Can we see what go on? Because in the exam, you're going to try stuff and think about it. It's not going to be perfect. So let's try the 155 now. So change this, guys, to 155 and see if we get the answer. We're going to do everything that we have to do to get that thing. Did we get it? When we multiply 290 times 180 times 155. Yay, we get it. We got it. All right. So in the exam, guys, you may have a theory, and when you work out the thing, you're not getting the answer. You're going to do what you need to do to get it. So when we did the first calculation and we got close to the target, we know we're gone over. That means we need to subtract something. So as Antoine was saying that we subtract 5 because of the thickness. Yeah. So 155. Very good. Very good. So you just show them the calculation that this is going to be. So the calculation then, I guess if you want to be fancy,
How many marks is this question?
3 marks.
Okay.
So if you want to be fancy, you can just say 300 minus 2 times 5. If you want to be fancy, show them say full of style. Multiplied by 190 minus 2 times 5 times 160 minus 5. So that's going to be 290 times 180 times 155. That's equal to 8,091,000. So if you want to be fancy, you don't have to be, but if you want to be fancy. All right? Lovely.
Question, sir.
Yes, Maji.
Why only 5 come out for the 160 and like a 10 come out for the 300 and the 190?
Guys, remember, so the height, you made the box. Let me just draw it inside and show you how I go on. So the inside box right here.
They just have to take care from that side.
No, just that side alone. Yeah, just that side alone, yeah. So remember, say this trough, remember, say this trough, when it connect, remember, say them cut off 5. So half of the top, the height, it's not half of the bottom alone now. It's just the top alone, because the trough is on the inside. So we cut off only 5 and not 10. And then mathematically, when you work it out, if you cut off 10, you're going to get less than what is required. So it's kind of like a more intuitive feel that I used of why I cut off 5.
All right.
Or actually, why Antoine cut off 5, not me. She suggested it. Geneva is saying that the edge would be 5 centimeters thick, right? Yes. Yes, I think so. All right. Boom. So calculate the volume of the wood need to make the trough. The volume of the wood. So what them ask us up here? The internal capacity, the volume of the wood. So to calculate the volume of the wood, we would need the volume of the external part. How much marks is it worth? 3, not true? So in order for us to calculate the wood section, you have to basically subtract the volume of the internal from the volume of the external. Do you get me? I say? Just imagine you have a box like this here, people. And you put another box. I want you to imagine like you put a box inside of a box. You see the space, you put a smaller box inside of a big box. There's a space that is around the box. That section is a wooden section. So how much volume would that take? Well, first you have to find the volume of the external. So volume of the wood would have been simply equal to volume of external, so volume xt, minus volume int. So the volume of the external minus the volume of the internal. This is a shorthand writing, guys. So the volume of the external trough minus the volume of the internal trough. So volume of the external trough would have been simply what we were seeing earlier, the exact numbers that are on the diagram, which would have been 300 times 190 times 160. And you got what? What did Antonia get? I'm seeing it in the chat. 9,120,000. Right? And then now we already have the volume of the internal, because we did already get the answer from up here, which should have been the 8 million that we have up here. 8,091,000 here. So if you subtract the volume of the external minus the volume of the internal, then you'll get the volume of the space left between them. How much you got? Right, so that would be 1,029,000 cubic centimeters. Oh, and guys, remember, so we left off something up here, this cubic centimeter here. We left off the cubic. All right, so nice question there. All right. All right, so hopefully you guys catch on to that one. Farmer Brown must paint the internal surface of the trough. The internal, so then capitalize the word internal. So must paint the internal surface of the trough. Given that 1 gallon of paint covers this amount of area, determine the total amount of paint in liters. So several conversion is needed here. That is to paint the internal surface. So what they're looking for, let me just show you what the farmer try to paint. So the farmer is going to try to paint here, so inside here, so I'm going to try to paint inside of this thing right here, inside here, around the edge of my try to paint the internal part. All right. Now that internal part, ladies and gentlemen, is what we call surface area or curved surface area. Now, I'm not sure if anybody remembers when I was teaching this topic, right? And I talked about the cylinder. And we said that the curved surface area is the part that imagine you put your hand around a Pepsi bottle and you're drinking the Pepsi. I mean, I thought the fancy people them will cock off them finger, you know. We thought like the people them will hold the Pepsi bottle in the middle like so. Let me see if I can turn on my camera. Can you see my camera? Hold on, wait. Can anybody see the camera of? I don't know. It's alright. Don't get the idea. Don't stress it. So imagine you put your hand around a tissue roll or a bottle. That part there around is the curved surface area. And curved surface area, I'm breaking this down from this point of view here. Curved surface area is equal to perimeter times height. So jot that down if it's the first time you're doing this. Curved surface area is equal to perimeter times height. So that's the concept we're going to be using here. If we want to paint, first of all, to attack this question, we have to first find the area of that curved section go around. We want to find the area of that curved section go around. Now there's 2 ways to get this. I'm going to show you both ways. Don't want to limit you guys to anything. So there's 2 ways to get this. Let's go back up here. To find the area of that, the part that I've shaded in purple, all I have to do is find the area of this over here and multiply it by 2 because there are 2 of them. And find the area of this piece and multiply it by 2 because 1 there at the back as well. So I find the area of one side and multiply it by 2. I find the area of the other side and multiply it by 2. Now work with me now. We know that the height at the internal piece now, we know. So remember, so the internal piece is what? The height is what? 155. Right? Remember? The internal piece, the height is 150. You notice why they put this thing here in all caps? They want you to realize that the internal measurements you must use. So I'm going to show you the formula way. the perimeter would have simply been, so from the formula point of view, the perimeter would have been the edge going around here. This edge plus that edge plus this inside edge here plus that inside edge here. All right? That's the perimeter around here. So what would be those measurements now? The internal part now. It would have been 180 times 2, because our perimeter, you know, this plus that over there, so this piece over there plus this piece, so that's 180 times 2. So the perimeter then is equal to 180 times 2, because there are 2 of them, plus this piece right here, the 300.
Sir, you would, okay, yes.
The 300, I go minus the 10 again, because remember say, is this piece times 2, the one on the back there, so that's 180, so that's going to be 290 times 2. So this is the perimeter we're working out. So the perimeter is going to be 360 plus 580, 9 and 9 are 18, 118, all right, so that's 580. So the perimeter is going to simply be what now? 880, 940, all right. So the perimeter of the internal section is what? 940. But we have to times it by the height. And the height is what? So they've emphasized 155. So the reason why, ladies and gentlemen, they put this word internal in all caps versus everything else is Csec, or the examiner, is trying to get you to remember that, you know, if you use the 300 or the 190 or the 160, you have to use the internal measurements. So that is 155. So this will give me the curved surface area. Go ahead and multiply that for me, please. Oh, that was fast. My God. See what? 14. It's about 1 Why can't I read this number? 145,700. Oh my God. Square centimeter. All right. So the curved surface area. There was something all right, someone. Something all right, you know. Because this number that we're getting right here is less than, or maybe it work.
Sir,
What about the other walls?
sir,
Yes.
we said you should go back to the question, please. They said they want it in liters, so wouldn't you divide it by something to get the
We don't
answer
reach
in
we don't reach the part yet. We're finding the area first.
Oh,
And Twin said something about the other walls. Remember, you know, the formula itself, you know, covers the 4 walls, you know. The formula itself, you know, covers for the entire 4 walls, you know. Remember, I said curved surface area. So what about you have 2 different size? Yeah, it doesn't matter. It doesn't matter. The formula covers whether different size wall. It doesn't matter. I am thinking along the line that maybe I'm go paint the floor too.
Sir, for the gallon. No.
We don't reach the gallon part yet, you know. Or no, we don't find the area yet, you know. We have something what we have right down here, the 145,700. Yeah, you have 2 different size walls, Antonia. But remember that the formula for curved surface area, regardless. Alright, here what we're gonna do. Right? Here what we're going to do. There's always an alternative route. So if I'm in the exam and this happens to me, and I'm thinking, what I'm gonna do is I'm gonna find the area of this wall, this internal wall over here, and times it by 2. So let me see if I can clean this diagram up a little bit. So what I'm gonna do is, sir, you would multiply the height. So you wouldn't, you're asking if I would multiply by the height? Oh, he would paint the bottom too, you think so? All right, so you're good. We are going to investigate. We're going to investigate. Don't worry, we're going to investigate. There's always a way around the problem. We can always fix the problem. You see, once you have an understanding of the math, you can always fix the problem. We can always fix the problem. We can always fix the problem. We can always fix the problem. Critical thinking is required. So this is what we're looking at, okay? Internal part of the world. All right, so this is what we're looking at. All right, so already know. So what we're going to do now, see, we're going to go think. Enjoy the maths, you know. Enjoy the challenge that comes with it. If you get it wrong, that doesn't mean that it can't work. So go find the area of that wall and times it by 2. All right, so what would be the area of that wall then? Length times width, right? So the length here would be the what? The 180. That's all. So this would be 180.
Sir, couldn't we just find the area of the bottom?
Alone.
And then we add it to the part that we have before.
Yeah, that's what I'm thinking. So that's what I'm saying. I'm going to do that, you know. That's why you see I haven't removed my calculation down here. Because I'm going to do it to see, to investigate if that's all we're missing. Because Antonia suggested in the chat that you would put in the bottom. So I'm investigating using a different row to see if I'm going to get my answer that way. So I'm going to use the 180 here and times it by 155. That's all. Length times width. So 155. So go ahead and multiply 180 times 155 times 2. How much you get for that? Length times width.
55,800. 55,800.
When you times it by 2?
Yeah.
All right. How much? Say it again.
55,800.
I'm write it down. 180 times 155 times 2. Say it again now for me. Sorry. Go again.
55,000.
Flat.
800.
Or 800. All right. Cool. So that will cover the area of these 2 red sections here. All right. Now we're going to do the back and the front now. So the back and the front now would be 290. So we subtract the width now. 290 times the height of 155. Do that for me now, Jafari. 290.
44,950.
Now take time with me the G. 290 times how much?
155.
155 times 2.
Times 2. 89,900.
89,900. All right. 89,900. That's it. Okay, sorry. Investigate, man. We investigate. All right. Okay. All right. So that would cover basically the back and the front. All right. Now, Antonia, we are about to prove something now, you know. Add those 2 and tell me if we get back the number we have down here. Add those 2 and tell me if you get the 145,700. Ah.
Yes, sir.
So Antonia, can you now confirm that the formula that we have up here covers for the 4 walls regardless of the size? All right, good. So we have that now. So you were suggesting earlier that he's going to include the bottom, or is that what you're saying? Because as we said, we're thinking together. Are you suggesting that the part of him say the Farmer Brown must pick the internal surface? Are we saying probably he's going? You believe so? All right, let us try it then. No. So Miss Gentles, now back to you now. We prove the point now. We know. So what we're going to do now is you suggested that we should find the area of the bottom and that's add it to the previous calculation, right? Miss G, that's what you're saying?
Yes, sir.
All right, so let's find the area of the bottom now. So the area of the bottom is the 290, right? That's up, times the what? 180. 290 times 180. So 290 times 180. So 290 times 180. Now we're not going to times this by 2 because only one of them. Remember, so the top is open, you know. So you can't paint here. You can't paint here. So there's no way to times that by 2. So go ahead now. What is 290 times 180? 52,200. All right? All right, good. So now, as Ms. Gentle said, we could just find that and add it to that. How much you get to that?
Mm-hmm. 197, 900.
197?
900.
197,000. So in either case, Antonia and Geneva, in either case, we're still getting less than what you're suggesting up here. But this is just what 1 gallon of paint will cover. So we shouldn't even make that scare us in our first place. It's not a case where we have to get more than that, because 1 gallon of paint, maybe it's a small like a straw of him up. So 1 gallon of paint, he may not need 1 gallon of paint. He may not need 1 gallon of paint, because we know that 1 gallon of paint will cover 280,000 square meters. It obviously means that his trough doesn't need a full gallon of paint. And this is just on the assumption that he's going to paint the floor. They didn't, them say internal surface, right? So internal surface, common sense, I would not have a trough for an animal and paint the wall and don't paint the floor. That would make sense, right? That would make no sense. So now that we have this now, you know. So now that we know that the amount of, so centimeters squared, so that is now the area of the internal surface. Let's go back up here and reason now. It says 1 gallon of paint covers this. Not true? So therefore, yes, Antonia, we would divide. So we would proceed now to divide this by 280,000. And we have to put the bigger number at the bottom because we already know we're going to get less than a gallon of paint. So 197,900 divided by 280,000. How much you got? How much gallon of paint we getting?
0.70.
Come on, 0.7 gallons of paint. So 0.7 gals. Now, it mentioned something to us earlier about what? Liters, not true? So, Simara was suggesting about dividing by something, because them italics, the liters, you know. I mean, whenever must divide first, you know. Oh, so him say 1 gallon is equal. Oh, sorry. So hold on, Antonia. Something first. We shouldn't divide yet, because he gave us a clue right down here. 1 gallon of paint is equivalent to 3.7 liters. Oh, so we're good then. No, we can divide. We can divide. We can divide. Yeah. So look now. Look at this now. So since, as we know, say the answer works out to be 0.7 gallons, not true? 0.7 gallons. And we know that 1 gallon, so 1 gallon is equal to this. So 1 gallon is equal to this, and we have 0.7 gallons. So it's going to simply be 0.7 multiplied by 3.79. And we go check. So how much liters of paint is needed?
2.65.
2.65 liters of paint.
So question, sir, you would touch the 145 after you get it?
145. Where did 145 come from? No, man, remember the 145, you know, was just the area of the walls. And Miss Gentle suggested that we just find the area of the bottom and add it back to it. And so come we get the 197 right here.
Okay.
So the 2.65 liters now, that is our answer here. This was a nice question. It's good to practice questions like these. It helps with the reasoning. There's so much mistake we made together. Because at first I see this question, you know. So, you know, obviously I'm going to have to be thinking on spot. But I think it's a nice question to really get us thinking. It's a nice question to, you know, work with brain and, you know, reason it out and see where we went wrong and why we're going wrong. So I appreciate this question. Not sure how many of you appreciate it, because some person don't really like a challenge, you know. Anything challenge them brain, them just no want to do it. But that's how it is, all right? So I think it's a nice question. All right, good job, girls. Good job, Miss Geneva. Good job, Javari. Thank you for contributing and guiding the process. Okay? All right. And good job to everybody else who is not talking. Obviously, me can't know not just quiet. Ashley, okay? Aria? Ayla?
Yes, sir, I'm good.
Hanson?
I'm good, sir. Just need to go over afterwards.
Yeah, man. Yeah, man. Shamir, you okay? Down quiet for most about half an hour now, you know.
Yeah, you lost me like 10 minutes ago.
Aye. But you watch the
Yeah.
recording.
I will.
All right. Cool. I'm going to be posting it right after.
And this was not
Sorry,
a good
I'm not going to be
question.
posting it after publicly. I'm just going to be sending it to you all individually because I'm not making it public until next week.
Okay.
But I'm going to send it to everybody who is in the class. And make sure to message me after at 534-7434 or my personal number. That's when you guys have 220-7352. Just request the personal link, and then next week I'll release it to the public. All right, good. So we do question 5, you know. Good reason, not, you know, statistics. All right, so 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. So underline something, you know. 100 students, that's the population, were surveyed on the amount of money they spent, The table below shows the results as well as the midpoint of each class interval. So we spoke about this already, guys, that these things over here are called class interval. I have a funny way with them write it still. So let me just understand what this is. This is saying that in this class right here, the money spent was greater than $50. So that means they would have had to spend 51, 52, 53, all the way up to 59, all the way up to 60. So this will include, this class here includes numbers from 51 all the way up to 60. This class here involves numbers that are greater than 61, greater than 60. So 61 up the way to 70, 71 up to 80, 81 up to 90, 91 up to 100. All right, so make sure you remember that these are called class intervals. No. So sometimes you have to stop and teach, you know. All right. What's going on here? All right. All right. Can anybody tell me what these are called, please? These numbers right here. What are these numbers called right here? There's individual numbers at the side. Anybody knows what they are called? Nobody know? Oh yes, correct, Antonia. They are called limits. Guys, give me 1 minute. Let me talk to my employer. I'll be right back. All right, I'm back. All right, so just make some notes as we go along, guys, because I don't like to teach just the questions and then now I'll go on. All right, so 50, 60. So those are called limits, ladies and gentlemen, folks. They are called limits. All right, good. So I just wanted to mention that. All right, can anybody figure out how it is that they got this 55, 65, 75, 85, 95? Can you figure out a pattern as to what you think they did to get the 55? What do you think they did to get the 55 and the 65 and the 75? Add 5? Kinda. But we would need an actual formula that would make us get that. So adding 5, but not all the time I got to add 5. There's something that we can do that will always get us the midpoint. Yes, Antonia, correct. We add the upper and the lower limit and divide by 2. So if you notice here that we added the 50 and the 60, and we got 110, and we divide it by 2, and we get 155. So that's yes, question. Yeah.
Can I run over that again there?
As in how we get the 55?
Yeah.
We added the 50 and the 60 and divide by 2.
Oh, okay.
We're trying to get in the middle of each class interval. So to get the middle of anything, you have to add the upper and the lower and divide by 2. So if you realize that in between 60 and 70 is 65, in between 70 and 80 is 75, in between 80 and 90 is 85, in between 90 and 100 is 95. All right, everybody get that?
Yes, sir.
Gucci. Now it says, using the table, you are to determine the modal class of the amount of money spent, the modal class. All right, anybody remember what mode means? Remembers or know, or are you familiar? That means our statistics class in the week is definitely needed.
The sum?
The most repeating? Some? Not quite. It's the class that has the highest frequency. So which class has the highest number of students spending money?
90 to 100.
That are 22, MG.
No,
Bigger number there.
80 to 9. No, 70 to 80.
Good. So the answer for that question is going to be the class 70, right? Just also you see it. 70 is less than or equal to x. 80. Good. That's the answer. So this class had 31 students. So we had more students spending $70 to $80 than any other class. All right, so that's the modal class. Next question. Calculate an estimate of the mean amount of money spent. Calculate an estimate of the mean amount of money spent, giving your answer correct to 2 decimal places. So to get the mean, ladies and gentlemen, we need to multiply, or we need to create a column here. And this column is going to be called your FX column. Because you'll have to multiply. You see, because we don't know exactly what amount of money was spent, we just know that the money spent was between a certain interval. We have to use the midpoint as an estimate. So we have to create what is called an FX column. So the FX column now will tell us that we should multiply the F values by the X values. So help me now, guys. What is 7 times 55?
385.
All right, continue. What is 11 times 65? 'What is 31 times 75? Oh, Anthony, you gone left me. 2325. Okay. What is 29 times 85? 2465. And what is 22 times 95? 2090. All right, guys, can somebody else confirm those answers, please, before we move on? I don't want to turn back. Can you confirm, as in you're working it out yourself and you're confirming on all those answers?
Yes, sir.
Yes, sir.
Can confirm. Good, good, good. I don't want to turn back and say we make a mistake. All right, good, good, good. Lovely. All right, now, that's the FX column. Now, surely, at some point, maybe you would have seen this thing and it confused the hell out of you. So mean, which is X bar, is equal to, have you seen this thing before? Have you ever seen that before?
Yes, sir.
Yes, sir.
Whether in my class or class before this year, I wonder what this mean. All right, so you see that E symbol that you're seeing here is just our statistician's way of telling you to add something. So that is what we call the summation symbol in statistics. Just like you have this symbol here that means addition in arithmetic, we have a symbol that means addition in statistics as well. So that is telling us that we need to add up the FX column. So this means add up the FX column. And then this means add up the F column. So go ahead and add up the numbers that are over here, please. Add up these numbers over here. And somebody else, whatever answer somebody say out, please somebody else can confirm it before we move to
12 back up the syrup on the table there. $7,980.
What you get?
7,980.
Yeah, man, I'll get the confirmation in the chat from one train, yeah. 7,980. All right, and add up the F column. We don't have to add up that. I already tell you 100 people. Sure. If you want to add it, you can. But I'm already tell us 100 people. All right, so when you get the answer, please round it off to 2 decimal places, please.
$80.
80 flat. Oh, 79.80. That round off, right? It's rounded. All right, so I'm gonna say it rounded. All right, cool, no problem. All right, and that's it. Oh no, we haven't talked about that's it. Question down here. Damien reports that the median amount spent is 84. Briefly explain why Damien's report could be correct. Could be. So let us find out what the median is first. For the median, right? The median, let me just work this out here. So we know the symbol for median is Q2. So Q2 is equal to the total population n plus 1 divided by 2. The population is 100 plus 1 divided by 2. So it's 101 divided by 2. The median is located at the 55th. No, the 58.5 value. Let me get 55 from. So the median is located at the 58.5 position. Now, if we go back to here and go up here, we have to create something called a cumulative frequency. All right, we have to create something called a cumulative frequency. Let me see how much marks it work. If you see if it work my time, it might be at 1 mark. No, sir. 1 mark. No, I'm not going to show all of that for 1 mark. Sorry, there has to be an easier way. No. So the median is 85. him say the median spent is 84. So basically he's saying that the median might be in this class. Come see what I'm going on. So here we're going on 1 mark. So I'm gonna go back and write back what we just do. So the median is actually equal to n plus 1 over 2, 100 plus 1 over 2. So the median is located at the 58.5 position. So we need to find out where would the 58.5 number be. 58.5 must be at the 51st or between the 51st and the 52nd number. So 51st and 52nd number, that's where it would fall, right between there. So let's go back to our frequency here and see. 7 plus 11 is how much? Work with me, guys. We want to add until we reach 5th.
18.
18. Add 31 to that.
49.
49. So you see right here, so right at this class, up to this point right here, so we have 49 people recorded, which means that the 50th, 51st, and everything after would fall into this class. So he's correct. So how would you explain this here then? You're going to say, so how would you explain it? You'd show your calculation here and you'd say, since Q2 is at the 50th.5 position, then 84 would be probably a number that is between that is after the 49th position or something like that. You'd write something in such a way that would say to them that, okay, then at the 49th number, at the 58.5 number, you'd say probably like the 58.5 number falls in this class. You'd write something like that. I'm not sure if you get what I'm trying to say. When we work out the median, we find out that the median is at the 50th.5 position. Our calculation will then show them that, okay, the 58.5 position is located in between 80 and 90, and 84 is between 80 and 90. So once your explanation makes sense, you'll get your mark. All right, and that is it for that question. All right, so the two-way contingency table below gives information on the mode of transportation for the school, for mode of transportation to school for the 100 students. Let us see if we can understand the table and what it is saying. So we have boy, girl, and total, right? We have 15 boys that walk. We don't know how many cycle. 14 drive, and in total, 48 boys are in the class. We don't know how much girl walk, but we know say 18 of them cycle. We know say 26 girl drive, and we don't know, we can't figure out how much girls are in the class as yet. Well, obviously
15, 14, and take out from 48.
All right, so hold on. Which one you work out? This one you work out?
The boy.
The boy.
So that's
you add
15.
14 and 15 and take it from what?
48.
All right, how much you get when I do that?
19.
All right. And what would you do now to get this number right here? What do you think you'd have to do to get that number? That is correct, Tanzania. Take 15 from 23. How much you got? 8? And what would you do to get this number right here?
19 plus 18.
Correct. That's how much?
37.
37. All right, and confirm it. Add 23 and 37 and 40. You must get 100.
Yes, sir.
Good, so good to go. And how would you get this here now? This would be 52, right? And if you check all the numbers, then adding across gives you the answers. Adding down gives you the correct answer. So you're good to go then. All right. So it says complete the table by filling the inserted values. Easy maths that we can scrape up the 2 marks and go on. A student is chosen at a student is selected at random. What is the probability that he or she was being driven to school on that day? So a student, they never say boy or girl, but a student. So the question is, so it was driven to school that day. So how many persons were driven to school? 40, that's correct. So hold on, probability is favorable over possible. And the amount of persons that were driven to school on that day was 40. And the total amount of persons in the survey is 100. So the probability is 0.4. All right, if you want to write as a fraction, you can write 2/5. All right. So one of the girls is selected at random. What's the probability that she did not cycle to school? So the question is, how many persons did not cycle to school? This more I know. This more I find out if I now get this. How many persons did not cycle to school?
Say I add the 23 and the 40 and take away 37.
And take away 37?
Yeah.
No, try again. Close, my boy. Take away 37. You sure? Did not cycle to school, you know?
Yes, sir. I remember at 37 cycle, right? And who walk at 23 and drive at 40 said that.
So when I just add the 23 to the 40, you're done.
Well, yeah, could I do that too?
Because if you add the 23, you know, and add the 40 and take 37 from it, that doesn't give you how much person cycle. We know how much person cycle. So therefore, everybody else don't cycle.
That'll be 63.
So 63 over 100. And the answer is going to be 0.63. That's it. Oh, but hold on, 2 marks, you know, so you have to show working out. Careful. So you'd say number of persons who did not.
Hold on there, sir.
But it says
says
girls.
girl.
A girls?
It says girls.
Oh, Lord have mercy. Ay. So, a girls. Hold on there now.
There would be 8 and 26.
Right. That's a Shamir. You catch me. You catch me. That missed me. I never see the girls part. Sorry, I overlooked the girls part. Very good. So the probability of who did not cycle to school would have been this thing. But girls, very good, guys. Very good. You're paying keen attention. That's good. Although we're tired, still a fight. Very good, people. Very good. So it's going to be 8 and 26. How much is that now? Sound like 34. Sound like 34, man.
Yes, sir.
And you see show working here. Don't just write down the answer like that. I think you're gonna get the marks even, but show working out to be safe. So 34 over
0.34.
0.34. Come on, make sure you know it says girls run that did not cycle to school. Okay. I don't know why I feel wrong. The 2 marks are bother me. It's too easy for that. No. Something off, guys. Something feel off. Yeah.
I'm thinking if you could add the 8 and the 26 and then subtract it from 52 and then use the 18 over the 100. Is it the 100?
It says did
18.
not, you know.
Yeah, but
so how many did not? These persons cycled, right?
Mm-hmm.
So these persons did not, correct?
Yeah, that would be 34.
All right. And the question, my problem now is how many persons in total did not cycle to school? And this are the 2 marks then. It just feel wrong. We know how much persons, so we know how much person did not cycle to school, right? 8 and 26. But what's the total amount of persons? Boy and
You
girl.
wouldn't take away the 34 from the 52.
34 from the 52.
Yes, sir.
But that would have give us 18.
And it's 1 girl.
Yeah, I hear what you're suggesting about adding 8 to 26 and taking it from 52 is kind of just writing on 18. What would be the point of doing that if we can already see the 18? My problem is the 2 marks right here. So C-set don't give a 2 marks like that. Nothing is that easy with them people here. Set them and set you up.
Sir Antoine sent something in the chat.
Oh, 34 divided by 52. Yes, that could be a possibility. Because them said girls chosen at. What's the problem is that she did not cycle to school. Yeah, man. I feel like this up. So you see, after we add the 18 and the 26, we get 34. Right? We have to divide the 34 by 52 and not 100. Because if you divide it by 100, you'd be comparing the amount of girls that did not cycle to school based on the population. It said girls selected at random. So it had to be a girl from the group of girls. So the 34 here.
0.65.
Yeah, the 1 mark. The 1 mark when I get right also. The first mark would be getting from saying 8 plus 26. That's the first mark. If you get the favorable. But then the other mark comes from the 52, knowing that you have to use this 52. How much you get? 0. How much?
65.
That's on. This feel better. Doing maths for so long. Yes, Antonia, you're correct. So 0.65. I feel like this is a better answer. And it makes more sense to me. I feel like this better. Yeah, I feel better with this one. All right, so that is it for that question. All right, and now it's 3:18, and we're going to move to our final question to close off the marathon for today. So very nice. Questions 1 to 3, and then we meet the exam in the middle. All right, lovely. So good reasoning again, guys. Good reasoning again. Mistakes are imminent. If we don't think carefully, we can make mistakes. So we have to we never write down the answer. We have to think about what we're writing down. Lovely. Last one. All right, let's see if we can wrap up this by 3:30. The diagram below shows 2 lines, L1 and L2. And you can clearly see the lines. Let me identify them for you. L1, and L2. You can see them. I put them in a different color so you can see them. So L1 and L2. All right, good. What are they saying now? The equation of L1 is x plus 2y equal 10, which you can see right here. And the line L2 passes through the point 0, -5. So it passes the y-axis at 0, -5. We know that much. So L2 passes the y-axis at 0, -5. And look at the word with them. Look at the word that them bold. Perpendicular. My face-to-face students, we met a question that dealt with this perpendicular concept yesterday. So let us hope that it comes back into play here. Express the equation L1 in the form y equal mx plus c. This part is really easy. Because all you have to do, ladies and gentlefolks, is get y to be by itself. Yeah, man. So don't make them throw you off. So they gave you the equation x plus what? 2y equal 10. Help me to get y by itself. What do I do?
Care over the 10 and put
y by
2y
itself, sorry.
equals
2y equals 10 minus x.
Oh,
Yeah.
2y equals 10 minus x. Put the x in front of the 10, please. So we can get the x, the mx and the c.
And
So
then
minus
I go divide by 2.
minus x plus 10. Now, please bear in mind now, guys. Not if you put the x after the 10, no, you're not wrong, you know. So don't add it. Not say you're wrong, you're right. But we kind of prefer if the mx is at the front and the constant is at the end. And then you're going to divide by 2.
And why the by itself now?
So then you end up with y equals what? What am I going to write?
X plus 10 over 2.
We want something in front of the x. We want it clear.
Minus x.
Minus x, something.
Minus 1x.
1.
Minus 1 something. Minus 1. Oh, yes. Minus 1 over 2. So 1 there, sign. So minus 1 over 2x plus 5. All right, plus 5. All right, so we want to write it like that so we can clearly see the numbers in front of the x and the 5. All right. Now it says state the gradient of L1. Where do we find gradient?
Rise over run.
Yeah, but you can use that when you're on an actual graph paper. But looking at the equation,
y2 minus y1.
we don't have the points then. So we don't want to use
The
that. Look at the
gradient is
equation.
negative half x.
No, negative half. So m is equal to negative half. All right, so let me just give some clarity because I hear some answers coming in. y2 minus y1 over x2 minus x1. That only works if you actually have the coordinates that are on the graph, or they gave you the coordinates. Rise over run cannot work here because you can't see the numbers on the graph. So when you're looking for a gradient, you have to look for the gradient using the equation, because in y equal mx plus c, m is known as your gradient. So I love the suggestions coming in, but try to get it together, guys. Know when to use the formulas. All right. The gradient, when you get the equation, the gradient is in front of x. When you get the points, the gradient is y2 minus y1 over x2 minus x1. And when you're on the graph, it is rise over run. So again, this is another structured video that I have. All you have to do is just text me which one you want to get your clarity where you need. So that's the gradient. All right, it says, hence, well, one of my favorite transitional words. Why? It connects my previous calculation with what I'm about to do now. So hence, we are to determine the equation of L2. So we know that the equation of any line is what? Y equals mx plus c. And we know that m is the what? Gradient. But the key word here, from way up here, the key word is what? Perpendicular. So what do we know about perpendicular? Just like I gave my students yesterday, write this down for me, guys. If two lines are perpendicular, that is correct, Antonia. Write this down for me, guys. If two lines are perpendicular, then the gradient of the second line, oh, partially correct, Antonia, you left out something. Then the gradient of the second line, that means M2, the gradient of the second line, is minus 1 divided by M. M1. So anyhow you find out, or they're telling you that two lines are perpendicular, then once you have the gradient of the first one, you're just going to simply divide it into negative 1. So the gradient of the first line was actually
M2, that's there.
Yeah, M2. That's the gradient of the second line. M2 is related to L2. M3 is related to L3. So negative 1 divided by negative a half. Keep change flip. Keep the first. Change the sign. Flip the last. So negative 1 multiplied by 2 over negative 1.
Can you go over that one, please?
No problem, I can. I would be willing to. All right, so go back again.
Thank you.
the equation of any line is y equal mx plus c, right? But we already have the equation of the first line up here. We already have it as y equal a half x plus 5, right? So now the relationship here, the hence, this keyword right here, hence, it is connecting what we just did with what we're about to do now. So this hence is saying that take the gradient that you got from the first line. This was the gradient that we got for the first line. And as the instruction or the information suggests that if two lines are perpendicular, sir, how do you know it's perpendicular? They said it right up here. If two lines are perpendicular, here's the rule. The gradient of the second line, which in this case we're going to call it M2, is equal to -1 divided by the gradient of the first line. And we already know that M1 from up here is -1/2. So that means that the new gradient, that's the one that's for the perpendicular line, is equal to -1 divided by the gradient of the first line, which is -1/2. So -1 multiplied by 2 over -1. Keep, change, flip. We keep the first, regular fraction, change the sign, flip the last. And if you do the fractions nicely, you realize that -1 cancel out -1. So M2 works out to be 2. So the second line business, this L2 what I'm talking about, the equation is going to nicely work out to be y equal, the new gradient is 2x, not true? And look at L2 now, at the graph. L2, this line right here, is crossing the y-axis at this number right here, which is -5. So just simply bring the -5 right here. There, that's the equation of the line. Okay, because remember, in y equal mx plus c, m is your gradient, and c is known as your y-intercept. It represents the line, the point on the y-axis where the line crosses, the point on the y-axis where the line crosses. All right. Again, I have a very, well, I've been told that that video that I made some years ago, I put a lot of effort into that video. So I've never really tried to make a new video on this, right? But equation of a line, length of a line, midpoint of a line, that kind of stuff, I have an exclusive video on that breaks down everything to the T. I think Miss Gentles, did you watch the video today? I think you had made a comment on the channel.
Okay, sir, you need to watch it again though.
Okay, just to catch up on it. All right. All right. And ladies and gentlemen, let's wrap it up now. I think that this is my class favorite, this f of x business thing here. So given that f of x is a third x plus 4, and g of x is 3x over x plus 1, what is f of 9? Somebody explain to me, how do we get f of 9?
So that I have a half 1 over 3 times 9 plus 4.
1 over 3 times 9 plus 4, correct, sir? How do you proceed from here?
Cancel the 3 and the 9.
Very good, sir. So what would we end up with here?
7.
That is correct. 3 plus 4, which is 7. Excellent. Good job. How much marks that? I'm stingy. 1 mark. Okay. No problem. All right. How do we work out this? Oh, everybody good with that? I think everybody's good with that one. I think everybody's good. Everybody's good, right? I think so. Yeah, man. Everybody good. All right. How do you deal with that one?
Put the g function into the... Put the 3 into the... -3 into the g function, and what you get of the g function, you put in the f.
You're my grade 1 student, man. My God. If you try something next week, Tuesday, I'll show them what time of day it is. If you try to send this come my boss. So we're going to put the -3 here. So g of minus 3 is equal to, put the minus 3 right here and right here. So we're going to say 3 times what? Minus 3. So 3 times minus 3 over minus 3 plus 1. Minus 3 plus 1. 3 multiplied by minus 3 works out to be minus 9 over negative 2. And that works out to be 9 over 2. And just in case you're asking me, sir, what if I turn it to a decimal? Nothing wrong with that, but we don't really like that. We don't like decimal. Tell you all the time, we don't like decimal.
So negative 9 over 2 becomes positive 9 over 2?
Yeah, because the two negatives cancel right here.
Okay.
All right. All right, and as Cohen suggested that after we get the 9 over 2, we're going to plug it into F. So put back the 9 over 2 right here. So we're going to have 1 over 3 times 9 over 2 plus 4. How do we proceed from here?
Cancel the 3 and the 9.
Easy, easy squeeze, my boss. And what do we end up with after we cancel out now?
We have 7 over.
If you
No.
try that, is sir. Don't even do that. 3 over 2 plus 4.
After the
LCM.
LCM, yeah.
Don't do that. Not now. LCM is what?
2.
2 into 2 goes 1 time, times it by the 1 up here. And 1 into 2 goes 2 times, times by the 2 up here. 3 ones is 3. And 4 twos is 8. So we end up with a nice result of 11 over 2. All right. And the final question that takes us into getting our 100%. Because we're going to get no question wrong so far, working together as a team. Determine the value of x, for which g of x is 5 over 2. Now, yesterday, I warned my students, that g of 5 over 2 is not the same thing as g of x.
5 over 2 equals the g function.
All right. So hold on now, come on. Make sure not warn, but I made my students in the face-to-face class alert that Csec loves to do these things. This is how they catch you off guard and take away like 2 points or your 3 points then. G of 5 over 2 is not the same thing as g of x equal 5 over 2. What this means is that this g symbol x, this g of x symbol here, will be replaced by 5 over 2. So if we go back up here, I will go back to the g function up here. This g function here, 3x over x plus 1. So 3x over x plus 1. And then say g of x is equal to that. We're going to simply replace this symbol right here with 5 over 2. So 5 over 2 will be equal to 3x over x plus 1. All right, so we're solving for x now. Solving for x. Now, last one, guys. How much marks it worth? 2 points. What would I do now to get x?
Multiply everything by 2.
We can't do that. No. If I multiply, I see, so when you have it like this, I know what you're doing, but in this case, you can't do that. Because if you multiply by 2, you won't be able to get rid of the x plus 1. And if you multiply by x plus 1, you won't be able to get rid of the 2.
And cross multiply.
Miss Gentles, oh God, on my side. Oh God, take time with me. Yes, Miss Gentles, oh Lord, Jesus, take the wheel. Cross multiply. And do you see it like that now, my G? when you have like some funny stuff down on the bottom, but you have something over something equals something over something, cross multiply. So you're gonna say now, use the 5 to multiply the x. This is gonna be 5x, and 5 times 1 is 5. You know what? Hold on. Let I write it down. 5 open bracket x plus 1, and that's equal to 2 times 3x. You know what? Let me put it in a bracket. 2 times 3x. All right, now ready now. 5 times x, 5x. 5 times 1, 5, equals 2 times 3x, 6x. All right, and then beat it bad now, bring over the 5x over there. 5 is equal to 6x minus 5x. Or the other way around, doesn't matter. So 5 is equal to x. What a lovely way to end the class. Lovely. And we not left out no question. And we get everything right. And we met up some challenges and we work together as a team and we figure some stuff out. I strongly recommend that you either watch over the full recording, which is too long, but I strongly recommend that you, when it's sent to you, any part of the paper that you found challenging, just zoom up back to that section there, and you can rewatch the section there that will give you a bit more clarity. All right, but this brings us to the end of another past paper and is leading us into our penultimate marathon, which is next week Sunday, where we will be working on the 2026 January past paper that was just completed a few months ago. That particular paper will bring us as close to seeing what CXC might hit us with. All right? But I thoroughly enjoyed this one today. I enjoyed it. I don't know about you, but I enjoyed it. And I hope you learned something. Yes.
Will there be, you said there will be a class tomorrow?
Oh yeah, man. So we're gonna have our marathons. Well, the free marathons that I'm giving, we'll be working on certain topics tomorrow. So we'll be doing a lot of questions on one particular topic. I don't know which. When I send you the message, you'll get the timeline.
Okay.
So from 6 p.m. tomorrow until 9 p.m. or 9:30 or 10 o'clock. It just depends. We are really gonna lock in, and make sure so who feel like them gonna get a 2, get a 1. Who feel like them gonna fail, go get a 3. Who feel like them gonna get a 3, go get a 2. Tomorrow now we are gonna ice out, fix up, trim up, clean up any little loose areas tomorrow. And do the thing. All right. If there are no questions or concerns, I'll see you guys tomorrow at 6 p.m. Be there to miss to this. Big up on yourself. Have a great day.
Okay, thank you.